Hello viewers, welcome back to the channel Maths with Berlin, and this is the new series, that is the master stroke series. So as you know, here we will be covering various JEE advanced level problems, and today's question is this basically, that is to find the value of the following limit, right? So give it a try, and if you have solved it, then it's very nice. You may check the answer at the end of the video, and those who couldn't solve it, for them the solution is coming up. So in this question, it is given to us to find the limit of the following value for n tending to infinity, n square into integral of 0 to 1 by n x to the power of x plus 1 dx, right? Now, basically what we need to do here is this one, right? Just look at this expression. This is x to the power of x plus 1 dx, right? This is the integral that is given to us basically. Now what most of the people will be approaching towards is I think Feynman, right? Yeah, so most of the people will be trying to do this in the following methods, right? Or let's suppose e to the power minus x or something like that. But believe me, it's very difficult using Feynman, and it's literally almost impossible, so believe me, right? Now what we did is, actually there is a very interesting thing, right? In limits, there is a very interesting property, as you can see, that if we take the following, most of it will not understand it. Let me write it down in a simpler way. It was given, let us assume x to the power x, right? Basically focus on x to the power x, and we can just multiply an x later, right? So basically we focus on this limit, that is this one, right? The limit of this part. So when it take a ln of this expression, what happens is x comes outside and it is ln x, it becomes x ln x. And let us suppose that the limit of this is basically L, right? So when we say that when x tending to infinity, right, we are given that, not x tending to infinity, basically if you see the limits here are 1 by n. Now 1 by n tends to infinity, it tends to 0, right? Tends to 0, yeah, sorry. So it tends to 0. Now therefore what we do is we try to focus on the limit of this expression when x tending to 0, right? When x tends to 0, we try to focus on the expression. So what we did is we tried to formulate this expression into the following one, right? Now this is an infinity by infinity format, right? And in infinity by infinity format, we can always apply the L'Hopital rule. So what we did is we applied the L'Hopital rule. And now what happens? That the limit L becomes to us as 0. But remember, we took the value of it as ln of something, right? We took the value as ln of something. So therefore it will be e to the power L, that is equal to 1. Basically here I have taken the value of this expression, that is x ln x, as ln of L. So therefore it has come that the value of L is equal to 1. But here I have assumed it in a different way. So the values of the expression are different as of now. So now moving on to the problem. So what I did is we took the RHL of this. There is another basic proof. Basically the another proof is RHL and LHL of this. So this was not so much intuitive, and it's very difficult if you solve it like this. So what I did is basically I took out the x to the power x as common outside, right? After that what happened is that is equal to 1. So I separated out the limit of it as equal to 1. So it just got cancelled out, as because it becomes as a value which is undefined, right? Now the value of x to the power x dx, not x to the power x dx, is basically x square by 2, right? This becomes x square by 2. Now if you put the limits, you will get the answer is equal to half, right? And you know the expression for y, right? This is the reasoning for y, that y is it that x to the power x limit x tending to 0 is equal to 1. Now that's it for today. So hope to see you guys in the next video. We'll be discussing various JEE advanced problems. Thank you.